Hi, my name is Odrus. I'm product manager for CSI drivers. Welcome to the Dell Technology session at SUSECON. Our today's session is called Gain the Full Control over the Storage Management in Multi-Tenant Kubernetes Environment. Today's session is presented by Florian Columbell, Tomer Nahumi, and I, Audrus Shepakis. Let's take a look at the agenda. We're going to showcase you persistent storage deployment and use with the Rancher RKE2. We will present you storage quota management in multi-tenant environment, as well as overview of the infrastructure for cloud-native applications, deploying and using PowerFlex as a persistent storage for cloud-native applications, as well as other enterprise capabilities. Many enterprises, many IT organizations are developing services that very much resemble cloud-like services. In fact, automate storage provisioning process, deploying new resources in seconds versus days, eliminating manual steps to reduce the risk are the primary objectives for today's IT organizations. Automation is a key element in modern IT operations. Infrastructure teams can take advantage of automation tools to manage complex infrastructure spanning compute, storage, and networking. Support continuous integration and continuous deployment cycles of applications, CI/CD pipelines. Deliver self-service experience for stakeholders consuming IT services. And last but not least, avoiding traditional scripting that is hard to develop and even harder to maintain. We would like to present you with Dell EMC PowerFlex storage array, which is software-defined storage, one of the flagship products when it comes to Kubernetes integration and using for Kubernetes persistent storage. In order to modernize effectively in today's world, IT organizations must be able to harness the power of software and embrace change while ensuring consistent and predictable outcomes. PowerFlex software-defined storage is designed ground up to do just that. It's a modern software-defined foundation that delivers extreme flexibility, massive performance, and scalability while simplifying complete infrastructure management. It is an ideal foundation for organizations to modernize their data centers and workload infrastructure. Let us take a look how performance, scale, and fluidity. PowerFlex is uniquely positioned to meet and exceed modern application requirements for storage, including the three factors I just mentioned. PowerFlex unrestricted I/O throughput, linear scale out to thousands of nodes, makes the storage uniquely positioned for modern applications, with a high demand for I/Os such as machine learning, artificial intelligence, CDNs, etc.
Helm is the package management tool of choice for Kubernetes in Rancher. The Apps and Marketplace feature is used to manage Helm charts, replacing the catalog system. The PowerFlex CSI installer can be added to the Apps and Marketplace tab. Built-in support will be added in the future. Once installed, each node pod is deployed on each Rancher worker node, in addition to an HA controller pair, which is used to communicate with the PowerFlex system. In addition, the installer creates storage classes which are used to provide storage to the pods. Now, let's create a new stateful set. We navigate to the Apps and Markets tab and select the CockroachDB chart, which is a distributed cloud-native database with multiple replicas. Each one has a dedicated persistent volume claim. We click on the Edit YAML button and set a storage class name to PowerFlex. Then, we click Install to deploy the application. The Powerflex CSI driver is responsible for the whole storage lifecycle, creating the new volumes, mapping them to the worker nodes, formatting them with a file system, and mounting them on the pods and the nodes. Within a few seconds, we can see that all the pods are up and running, connected to their new persistent volume claims, and the database UI is accessible. The CSI spec is updated every few months. However, there are a number of essential capabilities which are required by our customers and not covered by the CSI spec. To address these requirements, we've identified these needs and developed the CSM, the Container Storage Module, providing enterprise features for Kubernetes on top of the CSI spec. The LEMC Container Storage Modules aims at improving the observability, usability, and data mobility for stateful applications with Dell Technologies' storage portfolio. CSM, together with the CSI plugins and the pioneering app-aware, app-consistent backup and recovery solution, form the most comprehensive enterprise-grade storage and data protection solutions for Kubernetes from Dell Technologies. CSM contains a number of modules: snapshots, operational recovery and instant and efficient storage array-based snapshot through CSI, volume placement, intelligent volume placement for optimal performance, resiliency, node failure detection and recovery mechanism, observability, access storage metrics in tools like Grafana and Prometheus, data replication, industry-leading array-based replication to extend Kubernetes clusters across multiple data center, and authorization, access control and role-based access to storage infrastructure with user group support. At the moment, the container storage modules are supported with Powerflex. Additional storage systems will be added in the future. CSM Observability module provides Kubernetes administrator insight into the container storage interface driver persistent storage topology, usage, and performance. Metrics data is collected and pushed to OpenTelemetry Collector, so it can be processed and exported in a format consumable by Prometheus. Topology data related to containerized volumes that are provisioned by the CSI driver is also captured. The metrics and topology data are visualized through Grafana dashboards. SSL certificate for TLS between the nodes are handled by Cert Manager. CSM Observability can be natively integrated with Rancher built-in monitoring system, which consists of Prometheus and Grafana. It uses the OpenTelemetry Collector to push storage metrics so they can be consumed by Prometheus. Once Grafana and Prometheus are properly configured, customers can import the pre-built observability dashboards, and of course, each dashboard can be edited so customers can build their own customized dashboards. With that, let's see a quick demo. CSM Observability can be natively integrated with Rancher. By navigating to the Monitoring tab and clicking on the Service Monitor, you can find the OTL collector which pulls the data from the Powerflex system. If we navigate to the Grafana monitoring system, we can see that in addition to the built-in Rancher dashboards, we have 4 Powerflex dashboards. Each dashboard can be edited and customers can build their own customized dashboards as well. The admin dashboards provide visibility into the LEMC CSI driver provisioned volume characteristics in Kubernetes correlated with the volumes on the storage system. The storage consumption dashboards provides visibility into the total, used, and available capacity for a storage class and associated underlying storage construct. The I/O performance by node dashboards provides visibility into the I/O performance metrics, IOPS, bandwidth, and latency by Rancher node. You can select a specific node by name or an IP address and change the time frame. The I/O performance by volume dashboard provides visibility into the I/O performance metrics, IOPS, bandwidth, and latency by volume. Here, you can get very useful performance metrics about each and every persistent volume configured in the system. Together with PowerFlex UI, CSM Observability provides end-to-end performance monitoring solution for Kubernetes cloud-native applications running on PowerFlex, from the PowerFlex storage building blocks to the application persistent volumes. One of the most common questions I'm being asked by storage administrators is how can I limit my Kubernetes administrators from consuming all of the capacity of my storage arrays? Well, the simple answer is CSM authorization. Since there is no built-in capability in Kubernetes, we've developed our own mechanism which allows us to apply quota and role-based access rules that instantly and automatically restrict cluster tenants' usage of storage resources. Users of storage through CSM authorization do not need to have storage admin root credentials to access the storage system. The Kubernetes administrators have an interface to create, delete, and manage roles and groups that storage rules may be applied. Administrators and users may then generate authentication token that may be used by tenants to use storage with proper access policies being automatically enforced. With the help of CSM authorizations, customers can segregate the array usage between multiple tenants, control storage consumption with the help of quota, ensure that tenant cannot access storage from other tenants, create, update, or revoke storage access at any given point in time, audit storage access by the tenants, and hide the array management credentials from the CSI driver and replace it with a JSON-based token. The key concept behind CSM authorization is to minimize the storage administration exposure from the Kubernetes storage consumers. We are segregating the responsibilities between the Kubernetes administrator and the storage administrator by adding a component that acts as a proxy between the Kubernetes clusters and the management interface of the backend arrays. The storage admin will deploy CSM authorization and operate the component on several aspects, like maintaining a list of the tenants and maintaining the list of the arrays and the credentials to access them. And last but not least, it will maintain the relationship and quotas between those two. The steps of a normal workflows are: the storage admin creates a different elements, quotas, storage, system, token, etc. A cluster requests to create or delete a volume or snap. The proxy intercepts the query and validates it. In case of success, the proxy forwards the request to PowerFlex, and in case of an error, we forward the error to the querier. In case of success, we return success and update the quota accordingly. Now, let's see a quick demo of how it works. As you can see on the screen, there are 3 pods running on our Rancher cluster. Each one has a persistent volume claim of 8 GB. So we have a total of 24 GB allocated from our PowerFlex system. Now, let's see how CSM authorization can help us to control the storage consumption and allocation. First, we can list the registered PowerFlex systems and add additional systems if needed. Next, we can list the registered tenants and Kubernetes clusters. Now, I'm going to update the quota for this Rancher cluster and set a limit of 30 GB, which limits the storage consumption from the PowerFlex system. By running the list command, you can see that the quota has been updated. Now, let's navigate back to Rancher and try to increase the number of replicas from 3 to 4. As you can see, that pod and PVC status is pending. By running the kubectl describe command, we can see the following error: request denied, not enough quota. This means that the tenant reached its limit, and as a result, it cannot consume more storage from that PowerFlex specific system. In this case, the Kubernetes admin needs to delete existing persistent volumes or contact the storage admin and ask for more capacity. User applications can have problems if you want their pods to be resilient to Kubernetes node failures. This is especially true of those deployed with stateful set that use persistent volume claims. Kubernetes guarantees that there will never be two copies of the same stateful set pod running at the same time and accessing the storage, and therefore it does not clean up stateful set pods if the node executing them fails. CSM Resiliency is a module designed to make Kubernetes applications, including those who utilize persistent storage, more resilient to various failures. The first component of CSM Resiliency is Podmon. Pod Monitor that is specifically designed to protect stateful applications from various failures. It is not a standalone application, but rather is deployed as sidecar to CSI drivers in both the driver's controller pods and the driver node's pods. Deploying CSM Resiliency as a sidecar allowed it to make direct requests to the driver through the Unix domain socket that Kubernetes sidecars use to make CSI requests. CSM Resiliency is primarily designed to detect pod failures due to some kind of node failures or node communication failures. The diagram illustrates the hardware environments that is assumed in the design. CSM Resiliency's design is focused on detecting the following types of hardware failure, and when they occur, moving protected pods to hardware that is functioning correctly. The first one is node failure. Node failure is designed to be similar to a power failure to the node, which causes it to cease operation. The second one is Kubernetes control plane network failure. Control plane network failure often has a Kubernetes failure signature. However, if there is a separate array I/O interface, CSM Resiliency can often detect the array I/O network that may be active even though the control plane network is down. The third one is array I/O network failure, which is detected by polling the array to determine if the array has a healthy connection to the node or not. Now, let's see a quick demo of what happens when CSM Resiliency protects a workload and what happens when it doesn't. In order to show the power of CSM Resiliency, let's check the default Kubernetes behavior when there is a connectivity issue. As you can see, we have a stateful set of 3 pods. Each one is running on different Rancher worker node and connected to a dedicated persistent volume claim which is mapped to that specific node. I'm running the kubectl get pods command with the watch parameter. At this stage, I'm disconnecting both the management network and the storage network from one of the Rancher worker nodes. As you can see, the pod status has changed from running to crash loopback, as Kubernetes is unable to recover from a connectivity failure by default. By navigating to the CoreCouchDB UI, we can see that the pod is marked as dead. Now, let's see what happens when the application is protected by CSM Resiliency. In order to use this feature, we have to enable it during the CSI installation, and then we can label pods and stateful set with podmon label equals true to protect them from both Kubernetes control plane connectivity issues, node failures, and storage connectivity problems. As you can see, all the 3 pods are running again, and the database application is healthy. Now, I'm going to repeat the process and disconnect both the management network and the storage network from one of the Rancher worker nodes. Again, let's run the kubectl get pods command with the watch parameter and see what happens. If we navigate to the CoreCouchDB UI, we can see that the status of the affected pod has changed to suspect. The database detected that something happened to the pod, but it hasn't marked the pod as dead yet. If we go back to the Rancher UI, we can see that CSM Resiliency detected a failure, and now it is automatically rescheduling the pod on a healthy node and connecting the same PVC to that node. Within less than 20 seconds, the pod is up and running again, and the database is fully functioning.